Hello everyone. In this video, I'm going to cover the basics of hash function and Merkle tree. So these two terms we'll be using very frequently while talking about the blockchain technology. Before starting, I would like to quickly introduce myself. I'm Amrisha Kakoti and I'm working as a software engineer at Kpro Solutions Private Limited. Kpro is a leading provider in Datalake, cloud implementations, IoT, blockchain, analytics, machine learning, artificial intelligence, deep learning, and mobile application development. So without any further ado, let's get started with today's video. So the topics we'll be covering in this video are: what is hash, what is a Merkle tree, what does a block header look like, and a few advantages of Merkle tree. So let us start with what is hash. So hashing is nothing but taking an input string of any length and giving an output string of fixed length using some hashing algorithm. So when we are talking about the blockchain Bitcoin, it uses SHA-256, that is the secure hashing algorithm 256. Now let us see how it works. So we'll provide some input string and let us see if the output is some hexadecimal string of fixed length or not. So when we are providing this as the input string, that is hello, how are you, we get this output string, which is a hexadecimal number, which is nothing but the number consisting of the numerical 0 to 9 and the alphabets A to F. Now, one property of hash function is that it is deterministic. This means that no matter how many times you pass the string through the hash function, we'll always get the same result. So, if we pass the same string again through the hash function, we should get the same result. So, if we're passing the same string to the hash function again, we will get the exactly same result. Next, another property of hash function is that if you make even a very small change in the input data, the output hash would be completely different. So here you can see I have just replaced the comma here with an exclamation mark. But here you can see that the output string is totally different. There is no resemblance between the previous and the current output hashes. So another property is that irrespective of the length of the input string, the length of the output hash is always fixed. So here you can see I provided a very small input string, which is just a 2-letter input string. But you can see that the output string is of the fixed length. So it is this property that makes it extremely difficult to guess the length of the input string by simply looking at the output hash. So this is what basically the hash is. Next, let us see what is a Merkle tree. So Merkle trees are used in blockchain to validate large amounts of data in an efficient manner. Merkle root can be viewed as the signature of all the transactions within a single block. So in the public blockchain Bitcoin, to generate a hash, a block of transactions is run through an algorithm which can be used to verify if the current set of transactions is same as the original set or not. But the reverse cannot be done, that is the original transactions cannot be obtained. But to get the hash, the entire block of transactions is not run, but each transaction is hashed and each pair of transactions is concatenated and hashed together until there remains only one hash for the entire block. Now whatever I have said just now, let us see with the help of an example. Now let us consider a block in which there are 3 transactions, that is T1, T2, T3. So another point in Merkle tree is that if there is an odd number of transactions, one transaction is doubled and its hash is concatenated with itself. So since here we have just 3 transactions which is an odd number of transactions, hence this last transaction will be doubled and the corresponding hashes would be found out of all the individual transactions. So for example, the hash of T1 I'm considering as D1, T2 as D2, T3 as D3, and again T3 as T3. Now what will be done is that these 2 transactions will be concatenated and another hash would be found out. Similarly, these two transactions will be concatenated and another hash would be found out. So for example, I am considering the hash of D1 and D2 as D12 and D3 and D3 as D33. Now this process will be repeated until we are left with just one hash for the entire for all the transactions in the block. So finally, these two hashes will be concatenated and the final hash would be found out, which is the hash of the Merkle root. So this is basically what the Merkle tree is. Now here the hashes on the bottom row are referred to as the leaves, the intermediate hashes are referred to as the branches, and the topmost hash as the hash of the Merkle root. So next let us see what does the block header look like. So let us consider there are three blocks, that is block 1, block 2, block 3 with the block header. There are some more fields which I have not mentioned just for the sake of simplicity. So there are some other fields like version number, difficulty, etc. But just for the sake of simplicity, I have considered just 4 fields here. Now let us see how this Merkle root is calculated. So let us consider this block 2 in which there are 4 transactions, that is tx1, tx2, tx3, tx4. Each transaction's corresponding hashes would be found out, that is hash 1, hash 2, hash 3, hash 4. The two hashes will be concatenated and another hash will be found out. That is concatenation and rehashing of hash 1 and hash 2 gives us hash 1 2, and the same for hash 3 and hash 4 gives us hash 3 4. And finally these two will be concatenated and again hashed to get the Merkle root. So once this Merkle root is obtained, this is combined with other information like the previous hash, timestamp, nonce, version number, difficulty, etc. to get the block's unique hash. So this is basically what the block header looks like, and this is how we get the block's unique hash. Next let us see a few advantages of the Merkle tree. So one of the advantages of the Merkle tree is that it is very easy to check if the transactions have been tampered with or not. Now let me try to make you understand with the help of this diagram. So let us consider that this T2 transaction is tampered with and is changed to T21. Now on our previous slides we saw that even if we make a very small change in the input data, the output hash is completely different. So since this transaction is changed to something else, its corresponding hash will also change. So I'm considering that it is changed from D2 to D21. Now after concatenation of these two hashes, and when we again hash it to find the hash of these two concatenated hashes, again this will be changed. And finally the Merkle root will change. So if the Merkle root hash changes, it can be concluded that one or more transactions in the block have been tampered with. Next is, it is easy to verify if the transactions have been added or not. Now let us try to verify if the transaction T2 is added or not. So in order to verify the transaction T2 is added or not, we do not need the information regarding all other transactions and all other hashes of the Merkle tree. We will just need the transaction T2, its corresponding hash D2, and the sibling hashes, that is the hash D33 and the Merkle root hash, that is D1233. Hence it is easy to verify if the transactions have been added or not. So these are a few advantages of using the Merkle tree. Now let us have a quick recap of the topics that we have covered in this video. So in the beginning we saw what we mean by hash, and with that we saw a few examples of hash and its properties. Next we saw what is a Merkle tree, and then we saw what the Merkle tree looks like. Then we saw what does a block header looks like and how do we find the block's unique hash. Then we saw this two advantages of Merkle tree. Thank you for watching this video. Kindly provide your valuable feedback in the comment section below and let us know of any topic you want us to make a video of or any issue you might be facing in your project. You may write to us at feedback@kpro.co.in. Thank you very much. Let's keep learning.